So the die example is all well and good, but how does that relate to hypothesis testing? I mean, what is hypothesis testing? It sounds kind of fancy in terms of the language. So let's take a moment and break this down. Hypotheses are statements regarding a characteristic of one or more populations. Now, in Chapter 10, we're going to be working with one population, single populations. In Chapter 11, you'll be working with two populations at the same time, similar to Chapter 12 is two populations at the same time. Chapter 13 is actually more populations, could be 3, 4, 5, and so on. Now, the hypothesis testing is the process that we follow. It's a formal process based on sample evidence and probability used to test those hypotheses. You, in general, make a statement regarding the nature of your population. Then step 2 is you collect evidence, sample data, whatever, and then you analyze that data to assess the plausibility of your statement in step 1. Now, it seems kind of crazy, but they do this all the time. Like, I suppose that my new drug is going to cure cancer. Then I go give the drug to people, and then I check whether it did, right? Okay, so in this chapter, we will assume that the population parameters are certain values, and then we will test whether they make sense in light of known sample statistics. That's what our basic plan is. So let's think about what we just did with the dice example. So step 1, we assumed all dice are fair, right? All the dice in the class were fair. That was our assumption. It would be kind of a crazy assumption to make with a statistics professor, but you know, that's what we did. Okay, which means, by the way, the probability of rolling a 5 is assumed to be 1/6. All right. Then step 2. Oh, by the way, let me just say on another note real quick. You could say that P equals, if you want to do this with symbols, 1/6. That would be another way to put it. Okay, so that was what we assumed. In my class, my students assumed that. Then step 2, we gathered evidence. So in class, we rolled the dice 12 times, and we made a table of our results. That's what we did in class. Roll the dice and see what happens. All right, then we analyzed. Oops, stop that. I don't know why my caps lock is on. 1 second. There we go. I got it to fix. Okay, so we analyzed the data table. All right, and when we did that, what did we see? So we analyzed the table, and we realized, and we saw that Steve's results looked odd, unusual. All right, now how did we know that? So in class, it's kind of interesting when this happens because students will be like, cheater, liar, you know, so they'll go, oh, they must have had a rigged die. So you could know it from the p-value method, which would be the results, the chances of getting Steve's results are very low. Or you can know it from the classical method. Steve's results were far away from the rest of the group and the mean for the data. Okay. And so once you do that, you analyzed it and then you realized, oh, you know, something's up. And this is how you can tell, right? Something is up. So either the p-value method, which is I think the probability of getting what he got is so low that I think something's up, or the classical method, which is his results were far away from the rest of the group. The mean is where the rest of the group is going to be, right around the mean. All right, now we are going to keep using these all over the place. So let's take a moment and think about these. So in your testing population values. We're going to be testing population parameters. So you're going to assume a certain parameter. Like if you had the die in your hand, you would assume that it was 1/6, right? That's what you assume. Then you gather data, sample statistics to test those parameters. Now, what parameters can we make tests about? Well, they're the same parameters we could make confidence intervals for. So the population proportion P, the population mean mu, the population variance, which is sigma squared, and the population standard deviation, which is sigma. There, I typed them up a little bit better for you to see. So for population. So population proportion, which is P, population mean, which is mu, population variance, which is sigma squared, and then population standard deviation, which is sigma. Those are the four that you're going to run hypothesis tests on in this chapter. And by the way, in case you missed it, those are the four that you made confidence intervals for in the last chapter as well. Now let's look into how to make and write these hypotheses, these magical step 1 hypotheses that we're talking about here. Actually, you know what? I'm going to stop right here and I'll make that the video that where we start for the next video.